Good morning, everyone, and welcome to this workshop on inclusive strategies in making math accessible to blind and low vision students in higher education. I am Ryan Operario. I'm a math, SPED, and resource teacher at Zapatera SPED School, Cebu City. And I am thrilled to share with you some of my personal experiences and insights regarding this topic on teaching math to blind students. Allow me to preface my presentation by sharing with you that I myself am also visually impaired. I am diagnosed with Leber's hereditary optic neuropathy, and I am displaying an image on your screen that reflects my visual experience. Here are the objectives for this session. First is for you to gain an understanding on the unique challenges faced by students with visual impairment in learning mathematics. Second is for you to acquire essential knowledge and information on inclusive strategies in teaching math to students with visual impairment. The third objective is for you to be familiar with different assistive technology and resources available to support students with visual impairment in accessing and understanding mathematical concepts effectively. The fourth and the last one is for you to express concern for students with visual impairment, particularly in the challenges that they face in learning mathematics. Before we delve into our discussion, may I join you for a quick priming activity which I entitled Write What You Hear. And this is just a very simple activity, and I have two key instructions only. One is for you to grab a working pen and any piece of paper, and the second is for you to listen carefully to the math expressions that I'm going to dictate or read and write them down on that piece of paper. I'm just going to read or dictate four math expressions, and I'm going to read each twice, so kindly pay attention. Are we all set? Game na po ba ang lahat? I think we're all set, so let's start. For our first expression, we have 2 over 7 plus 3 halves minus 4. Again, it's 2 over 7 plus 3 halves minus 4. Number 2, x cubed minus 2x over x plus 2 minus 4. Again, x cubed minus 2x over x plus 2 minus 4. Number 3, 2 raised to the power of n plus 3 equals 2 to the power of 5 plus 32. Again, 2 raised to the power of n plus 3 is equal to 2 raised to the power of 5 plus 32. We're down to the last expression. I have here the square root of x squared plus y cubed minus z to the power of 4. Again, it's the square root of x squared plus y cubed minus z to the power of 4. Okay, papers up. Now it's time to reveal the expressions which I have in my presentation. You can see for number one, we have 2 as our numerator, and in our denominator, we have 7 plus 3 halves. And then we have minus 4, which is not part of the fraction or the rational expression. I hope most of you, if not all of you, got this one correctly. Marami po ba nakakuha? Great job. For our second expression, we have here x cubed minus a fraction having 2x as the numerator and a denominator of x plus 2 and minus 4. So I hope most, if not all, got this one also correctly. So perfect pa po ba so far ang inyong score? And good job for that. For our third expression, we have here on your screen an exponential equation. At the left side of the equation, we have the base 2 raised to the exponent of n plus 3 and equated to 2 raised to 5 plus 32. So I hope everyone got this correctly also. And congratulations po sa lahat ng nakakuha nito. And finally, we're down to our last expression, and this is a three-term expression, a trinomial. The first term is a radical expression. It's the square root of x squared, and the rest of the two terms or the other two terms are no longer part of that radical expression. So we have the square root of x squared plus y cubed minus z to the power of 4. So marami po ba nakakuha o lahat po ba ay nakuha ito ng tama? And congratulations po sa nakakuha nito ng tama. Marami po ba ang naka-perfect or lahat po ba ay naka-perfect? Medyo mataas po ang expectations ko sa inyo dahil kayo po ay mga math instructors na. And I have done this several times no uh, sa mga trainings that I did in the past in several universities, and kahit sa mga math instructors ay meron pa rin pong hindi ito nagigets no. And this is not just problematic to you, but this is even more problematic to a person who is or to a student who is visually impaired. So that is really a challenge. And this is again a personal experience which I have had uh, even during my undergraduate uh, degree in mathematics, and it actually perpetuated no hanggang nung aking when I took my masters or MAED in mathematics at Cebu Normal University. So this is a regular predicament of a student who is blind or low vision in a math class. The previous activity that we just had illustrates one of the many challenges that a student with visual impairment faces regularly in a math class. And actually, it's not just in the math class, but across the STEM disciplines, no? The science and technology, engineering, and math disciplines. And we will try to delve deeper into each of these challenges, no, so as to be able to address them later no, in this presentation. And as we try to understand each challenge or each problem, let us also try to reflect no, on our practices and how we can modify, how we can implement uh, ways or strategies wherein we can mitigate or even um, address these challenges. Foremost to the challenges that a student with visual impairment encounters in his or her math class is the ambiguity and inconsistency of spoken math. As you have noticed in our priming activity, there are really several expressions or several concepts, several symbols in math that if we utter them can be prone to ambiguous or to different interpretations. And some of these that you can see on the screens, and we had also in our examples or in the items that I had in the activity are are on rational expressions, no, fractions, also with exponential expressions or equations, as well as radical expressions. But certainly there are still more concepts or more symbols that are prone to be spoken ambiguously. Now, another thing is most also of our math instructors are not really aware, no, that they are able to speak these expressions ambiguously. And aside from that, the way that they speak, no, uh, these expressions is also inconsistent, no. For example, no, yung pagbasa sa superscript or the exponent, may iba na sinasabi raised to the power of, meron ding um, um, to the power of lang or raised to, etc. No? So, uh, it may not be problematic or it may not cause confusion doon sa sighted na student because he is actually seeing what is being referred to, no, by the math instructor. But for a blind or a low vision student who is not able to see the expression probably on the board, that can really pose several or that can really pose a challenge, no. But I know there are ways, no, there are several ways to do that. Probably you were thinking na bakit hindi na lang mag-pause, no? That can be a good solution, but how consistently can we do the pausing, no? But later on in this presentation, I'll be addressing this particular challenge. But this indeed is a major challenge that I myself am facing, no, even up to now. Like the expression that you have on the screen right now, we have there a radical expression, uh, square root of a plus b plus c. And if you try to analyze this, just by hearing that, now, if you just listen to someone uh, reading that, there can be three possible interpretations. No? One is that a is inside the radical expression or the radical sign. Another is that both A and B are inside or are enclosed in the radical sign. And of course, the last one, which is depicted on our screen right now, is having the three variables inside the radical expression. Now, I think you are already amenable that this is really a case of ambiguity and sometimes can also be a case of inconsistency. Another significant challenge that our students with visual impairment faces in their math class is the lack of accessible learning materials or learning resources. Uh, Kulang or talagang wala nung mga learning materials or math learning materials in braille format, large print format, and even digital format. Ano po. So, Napaka-unfortunate, but that is the sad reality that we are facing at present, no? So, but I think you are really blessed because you have the Philippine National School for the Blind, which is very proximate to your location, no? And also probably you can even reach out to the National Library uh, and probably other organizations that offer the production of these materials, no? So hindi lang po dyan sa mga formats na yun, we can also include the tactile graphics, no, which is also very essential in learning math concepts. And in my case, I'm also doing that here in Cebu, and I believe PNSB can extend that assistance to you, no, as this partnership is being forged between your school and PNSB. Next challenge that our students with visual impairment face is visualization. And as we all know, math is highly visual, and most of the concepts, particularly in dimensional mathematics, no, in in geometry and trigonometry, really require visualization. Meron pang mga competencies na you need to visualize because you need to rotate figures on your head, no, or you need to rotate them mentally. Uh, this can be very easy for a sighted student, but this is really problematic for someone who is blind or low vision. Although may mga exception, merong ding mga blind na these are outliers na talagang magaling, no? Probably their visual cortex is developed despite being totally blind, no? Meron talagang magaling sa ganyan, no? And several reasons can be attributed to that, no? Merong iba na talagang na-develop na yan mula nung bata pa. But going back to visualization, uh, hindi naman ito yung uh, wala ng solusyon, no? So meron pa rin talagang solusyon. And one of the solutions is the provision of tactile graphics, no? Tactile meaning something that they can touch, and graphics, of course, can be in different formats, no? And most likely it's a three-dimensional tactile graphics. Another significant challenge is spatial reasoning. Basically, spatial reasoning is just all about spatial relationships, no? So between an object to the other objects, no, and of course, no, doon sa position ng object na yon. And um, a skill, no, of this skill on spatial reasoning is very crucial in comprehending several concepts and principles of geometry and also trigonometry. So, kailangan talaga ito ng ating mga students regardless of with or without disability. And hindi naman siya imposibleng matutuhan ng ating mga estudyante. Meron lang talagang mga paraan. So that's why we need to know our students, yung kanilang profile, and how their acuity, no, in different aspects of mathematics, particularly sa case na to ay sa spatial reasoning. Another glaring difficulty or challenge is appreciating graphs, no, or diagrams and even charts, no? So obviously ito ay talagang mahirap sa ating mga kasamahan or sa ating mga estudyante na visually impaired. But there are several workarounds. One is the low-tech way, which is to provide tactile graphic. Although hindi ito ganun kadali na gawin, but providing such is really very helpful, no? But it also entails training and orientation doon sa estudyante. Hindi lang basta bibigyan mo lang siya nung graph or nung tactile graphics na pwede nang ma-explore tactually, and yun na, alam niya na. O hindi po ganun. Meron pa rin orientation. Kaya medyo may konting work, no, even right after producing an accessible material. Next challenge is generalizing. In math, generalizing is very important because uh, the things that we learn from one lesson or from one concept can also be generalized or can also be applied to another concept, and that is uh, applying this particular knowledge or learning to another context. Now, ito ay medyo problematic sa maraming visually impaired, but again, this has several workarounds, several solutions. Yung iba nabanggit ko na kanina, no? So, through the availability of learning materials and, of course, through assistance in direct instruction. At this point, let us move on to the things that we need to consider when teaching a student who is visually impaired. And what you can see on the screen is a glaring fact that we can actually observe, no, in our students who are blind and visually impaired. Most, if not all of them, can really memorize long verbal facts. And in mathematics, we have several concepts and constructs that need to be recalled and need to be remembered. No? So this can be a big help for our students who are visually impaired if they're able to recall concepts and theorems and also formulas and rules. No, so that is an advantage for them. So we need to consider this because this can also be a good way that we can facilitate the learning of our students with visual impairment. Another thing that can be worth your consideration is the ability of our visually impaired students to perform mental math calculations. And claim that it is imperative for them to be competent in mental math for them to succeed in higher education. And it's not just in the basic math or in the arithmetic part, but mental math can also transcend to other math areas, even higher math. Another important thing that you should know is that all mathematical expressions can be written in Braille. So our blind and visually impaired students can really write and take note of all math expressions because these expressions or these symbols have Braille equivalents. So wala na po talagang kawala, no? May it be in the basic math or in the higher math. Meron at meron pong equivalent na Braille symbol. So, pag meron tayong estudyante na visually impaired, pwede nating talaga silang mabigyan or maturuan ng mga even complex concepts dahil meron meron na silang equivalent ng mga o meron silang braille na pwede nilang gamitin sa pagsusulat. Another major consideration that teachers should note is that our students who are blind and visually impaired really need more time, no, in solving or uh, performing different math tasks because primarily because they're using a writing system that would take them more time to write a symbol than a sighted student who's just going to scribble or to just use a few strokes, no? So that is that really can be attributed to the writing system or the reading and writing system, and also the reading and writing speed, no, of the student. So kailangan talaga natin i-consider na medyo matagal silang magsulat, medyo matagal silang mag-solve And lalo na kung ang gamit lang nila ay yung kanilang writing slate and stylus, no? Because uh, they have to write down the given. In most cases, they have to write down the given and they have to flip the paper, tatanggalin nila, read again, follow through the solution, balik na naman yung papel, and that really takes time. Now let's move on to some of the factors that can lead to the success of our students with visual impairment in a math class. And one of these factors is their mastery of the Braille. Now that includes mastery of the literary Braille, the English Braille, and of course, mastery of the Nemeth Braille code, the code for mathematics. Now, uh, kung hindi nila kaya ito, hindi sila competent in this skill, ay talagang mahihirapan sila, no, sa pag-succeed sa kahit anong math class na papasukin nila. So this is really foremost of the considerations of the factors na kailangan equip yung ating mga estudyante or kailangan sila ay competent uh, Braille readers and Braille writers ng English Braille and also of the Math Braille. Furthermore, according to Dr. Abraham Nemeth, a blind mathematician, if someone who is blind and visually impaired is not really competent, no, in using his tool, which is Braille, and it is really improbable for him or her to succeed in any math class. And Dr. Nemeth is a one classic example of someone who really mastered Braille and really succeeded and eventually became a famous mathematician, not just in the field of visual impairment, but across uh, the regular uh, the regular mathematics. Another key factor for the success of our students with visual impairment is the quantity and the quality of their sensory inputs, particularly those inputs that relate to math. So, ibig kong sabihin dito ay kung marami silang na-acquire, marami silang ah, na napulot ng mga sensory inputs, at yung quality nun relating to mathematics ay mas may edge sila over those who are not really exposed, no? And this has been my observations in the few years, no? Although medyo matagal na, almost 20 years na rin ako sa teaching industry for blind and visually impaired students. Na yung mga malilikot, magalaw, uh, they are really those who would excel in math, and not just in math, but in sciences, no? So they're able to appreciate space because they love to move around and they love to touch different things. They love to manipulate and navigate things. And those are really essential in acquiring mathematical skills and then mathematical concepts and constructs. So, yun, isa rin yun sa mga major considerations or factors.
Okay.
Another glaring factor that is quite obvious is uh, the good foundation of our students in numeracy and other math skills. If they were taught in their basic education some fundamental concepts in math, and that would be a great advantage to them, no? Going to higher education. One key factor also is the availability of assistive technologies within the disposal of our students who are visually impaired. So if they have with them the right tools, the right assistive technologies in their toolkit, then they would be able to succeed, no, in any math class. I remember some anecdotes relating to our fellow visually impaired professionals who are successful in math and technology uh, industries, no, na talagang yung present, no, or the availability of assistive technologies is a great equalizer for them and a great tool for them to be able to succeed in math.
OK button.
Now that we have discussed different considerations and factors for our students who are blind and visually impaired to cope and succeed in any math class, let us now delve deeper into the inclusive strategies that you can also adopt and implement in your math class. First is in the preparation phase. Now, if you're able to prepare your lesson materials, kindly give your students who are visually impaired in advance. Now, that can be a few weeks or a few days or even a day before the actual presentation of the lesson. In such a way, the student who is blind and visually impaired is able to read it in advance, and when he or she is in your math class, is already prepared and will just be doing the connections or just be listening to you and connecting what he or she has just read and connecting it to the concepts that you are teaching. So medyo hindi na siya ganun ka-complex na dahil nabasa na, no, na pre-read na noong estudyante yung lesson. Now, preferably the format is electronic format, and in our case, we prefer uh, presentations that can be PowerPoint or Word documents as lecture materials, and these are made accessible if we produce this or if we encode this using um, math type, because that has a way to produce expressions in MathML and LaTeX, and but we can also directly input it on our word processors, particularly Microsoft Word, using the built-in equation editor of Microsoft Office. And of course, we also have that equation editor on our MS PowerPoint or Microsoft PowerPoint. In that way, if our blind or visually impaired students use his or her technology, which is mainly the screen reader, then that would be very accessible for him or her. Now, another alternative is for a sighted classmate, now to um, write or to give a copy to the blind student, and yeah, the support system of that student can read the notes to him or her, no? This can work in some context, but yeah, we need to also consider the context, no, yung sa inyong context yan, sa inyong school, if this is feasible. But if this is not feasible, then we can explore other options, no, like yun nga, provision in advance or provision of the learning materials earlier. And of course, we can also um, provide assistance, no, with if we have some math majors in your department who can also assist, no? In our time, we used to have that carbon paper, no, na nilalagay namin or binibigyan namin sa aming mga classmates, so that whenever they write, they also produce an extra copy, so they don't need to rewrite for us. Another consideration is if you are providing diagrams or um, graphics, no, in your learning materials, kindly provide some labels and descriptions which are clear and specific. No? Ano po? So that the visually impaired can easily understand the descriptions and also the surrounding texts of these diagrams and charts. Now, in reference to the provision of uh, learning materials in Braille format, it would be highly recommended, no, if you can forge a partnership with the Philippine National School for the Blind. I am positive that they would be extending their learning resources to you so that you can actually convert, no, your learning materials in Braille. Now, in such a way, our students can already have a an access, no, to your lessons. Moving on to the presentation phase, if you are presenting a concept uh, with the use of visual aids or visual learning materials, then it would be highly recommended that you would um, use alternatives such as tactile models or tactile graphics, and also make use of descriptions, no? Clear and specific descriptions, and even words that are relatable to the experiences of your students, particularly to your blind and low vision students. Now, if colors and layouts are essential in your discussion, then we would also be recommending that you would also describe that and include that in your presentation. In the instruction phase, if you are teaching a concept uh, in geometry or other dimensional mathematics, then we would really appreciate if you can provide your blind or visually impaired student uh, some manipulatives or tactile graphics now that he or she can use to be able to follow with your discussion. And there are other alternatives naman po, no, na pwedeng gamitin. You can even make use of paper folding. Um, you can also make use of cutouts and other materials. No? So at the end of this presentation, I'll be sharing to you a um, YouTube channel that which I am also part of, or I was a part of in the past, in creating instructional videos, no, particularly in teaching math to the blind, and that includes the use of manipulatives like paper folding, real objects, and so on. Furthermore, in your delivery, it is also recommended, or it's also a major consideration if you can be very descriptive in your discussion. If you can be very specific. Now, if you have visual aids or visual learning materials, or if you are making an illustration on the board, then you can probably describe the other things, no, that you have illustrated or you have drawn. Although you have just another inclusive strategy is to be descriptive and be very specific in the language that you use when you're doing your discussion. Earlier, we had our activity on the ambiguity and inconsistency of spoken math. And this is one way of solving or addressing such problem. If you can be descriptive, there are symbols within expressions that in some instances, uh, instructors or others who read math would likely omit, no, in the in the way they read these expressions. But if you can also include them, although it might sound kung ano yung very descriptive, pero in a way you are also helping. You are in the process, you are helping your student who is blind and visually impaired. Another is to be consistent. No, if you are keen on speaking a particular symbol using a that particular phrase or word, then if you can consistently use that in all your discussions, no, that would be a very good, a very big help for these students. No, may mga cases kasi na may mga symbols na binasa ng ganito in uh, the previous discussions, but same symbol is read differently naman in the uh, present discussion. So that can actually pose confusion. So if you can really be consistent, no, although we don't really expect that you would be very consistent or 100% consistent and 100% descriptive, but just having that effort to really extend your assistance by being descriptive in your discussion ay malaking tulong na po yan. In addition to being descriptive and specific in the language that you use, you can also adopt the math speak method or the math speak system. And this is the absolute solution in the ambiguity and inconsistency of speaking math expressions. Now, the math speak was actually developed by Dr. Abraham Nemeth in uh, in relation to the Nemeth Braille code. Now, how does this math speak works? No? So, basically, it's just a way of demarcating the beginning and the end of uh, some expressions which can pose ambiguity. No? So, halimbawa, yung rational expressions or fraction. In most cases, if we just utter a particular fraction, we don't know where it uh, starts, or most likely we know where it starts, but we don't know where it ends. Now, so if we can demarcate that with using some key phrases, in this case, we use the phrase start fraction. So in our first example, we have there x over y. We can uh, we can describe this by using the phrase start fraction and end fraction. So start fraction x over end fraction y, or start fraction x over y end fraction. And for our second example, which is a longer one, we even have a longer description. So first we have the start fraction x over y end fraction plus a. So take note there that we end our fraction in the denominator y, and we add another term which is a. And then this is equated to start fraction x plus a y uh, over y and fraction. Now, in this case, we know that our numerator has two terms because when we heard start fraction x plus ay, that means both x and ay are part of the numerator. And then we have over y. We don't have to say all over y because we know that the two terms x plus ay are all part of the numerator. Now, I hope you're getting the point now. So, demarcating the beginning and the end of the expression is crucial in the note-taking process now of our students who are blind and visually impaired. And with these examples, I think it's a bit clearer now for you how to do it. Now, in the case of exponents, then we have to also demarcate, no? Using superscripts. Yeah. So say 2 superscript x plus 3 end. We have to also demarcate where it ends. And also for rational expressions, we have also to put start root and end root. Now, in this case, we know where it begins and where it ends. In relation to your delivery and communication, your students who are blind and visually impaired would really appreciate if you can verbalize your solution, or if you can verbalize the proceeding or the things that you have written on the board. Now, if you're having a solution, if you can verbalize the step-by-step solution or the step-by-step process, then that would be very beneficial for your student. Another inclusive strategy is to approach your blind or visually impaired student during time where when you are providing a seat work to your class. Now you can um, set this time to ask him if he is able to understand your lesson, or if he has questions, no? Or if he wants more explanations, or if he wants more details on a particular aspect of your discussion. During assessments, one good practice is for you to make use of other ways not to um, provide such assessments. Now, you can have it done orally, or you can make use of some tactile diagrams or tactile models or tactile graphics, so that your student who is blind or visually impaired is able to perform, no, such assessments independently. Another is if you can provide some time extension, because uh, we already know that these students would require extra time in accomplishing some tests and assessments. So that would be very much appreciated if you can extend additional time, even just half of the regular time. Another inclusive strategy that we are using in our school, in our inclusion or inclusive classes, is the collaborative learning, particularly the think, pair, share, the TPS strategy. Now, in this way, um, most of our receiving math teachers are providing activities, and they would look for a uh, partner for our students who are blind and visually impaired in performing these activities now. So whether it's problem solving or any performance related to the lesson, uh, they would uh, they would assign a partner, and they would do this think pair share, no? So in the process, the student who is blind and visually impaired is able to communicate with sighted peers, and even able to share, no, his learnings from the discussion. Another strategy is for you to establish a partnership, no, with SNED teachers from PNSB, so that in cases of doubts and cases of challenges that you encounter, you can actually ask their help. Uh, Another thing is for you to really involve the other stakeholders, so the parents, the support system of your student, because after all, they are also very important, no, in making sure that your student is able to cope in your class. Another inclusive strategy that I myself have experienced when I was still studying in my undergrad and even master's is the provision of consultation time. This is not just for your student who is blind or visually impaired, but you can do this across or for all your students. But particularly for that blind student of yours, you can probably schedule an hour in a week, or depending on your availability, or even assign some math majors to assist, or peer tutors, no, in the process of providing your consultation time. Another consideration that I have been advocating, not just in higher ed, but also in the basic ed, particularly in my context, no, in the junior and senior high school level, is when there are assessments, no, or tasks given, that if they can lessen the number of items or lessen the workload, regardless of whether it's a test or it's an assignment, an activity, as long as the competencies that need to be measured are within the given number of items or the given workload, then I think it is still fine, no? Concrete example is that if you're having a lesson on simplifying or yeah, proving trigonometric identities, and you are providing a 10 item test to your class, then probably you can have it lowered to 7 or even 5, as long as you are testing the same competency or testing the same skill. Now, this one and all of the other suggestions that I have mentioned already, these are not actually prescriptive. No, these are just suggestions from my end. But this has been working, or these have already worked in several contexts, no, particularly in our context here. Another key consideration also is for you to be familiar with the different assistive technologies that your student who is blind or visually impaired is using. Now, in that way, you will be able to communicate with him or her in different modalities, no, not just through the tangible hard copies that you have, but even in other ways, no, like electronic formats. So mahalaga po rin talaga na kahit may konti kayong alam doon sa ginagamit na assistive technology ng inyong estudyante. Moving on to the accommodations that you can extend to these students. One is that thinking that or having the mindset that you need to provide the same information, or you need to provide deliver the same lesson to your students. Now, regardless of the disabilities of your students, hindi po tama, no, na ay blind siya, so ito lang yung ibibigay ko sa kanya, itong pinakamadali, or ito na lang na lesson, and I will skip this lesson because he is blind, no? In 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 my experience, meron talaga mga teachers na gano'n, ay ah, hindi ko na siya bibigyan ng ganito. So, ito lang yung lesson na pwede sa kanya. So, hindi po tama yun, no? Um, we are actually discriminating. We are depriving the student with the knowledge, no, the learning from a particular lesson that you skip. If you have, like, if you are struggling to deliver this particular lesson to the blind student, then you can probably ask for help, no? Meron naman pong pwedeng pagtanungan. Of course, you need to analyze what needs to be learned, and in that way, pwede kang magkaroon ng adaptation, or yung tinatawag din nating differentiated instruction na strategy, no? Although hindi ko na ilagay kanina sa mga slides, but I think you already know that, no, yung differentiated instruction. Ginagawa natin talaga yon to really cater, no, to the different intelligences na meron yung ating mga students. So kung may student tayo na VI at magaling siya sa music, and we can actually make use of that skill or ability of our student in relation to a particular lesson. So I think yung differentiated instruction naman ay quite a common strategy. No? Another accommodation is for you as instructor to be able to assign someone, particularly during quizzes or assessments, to read to the VI student. But of course, if you can do it personally to be the one to read, and then that would be very great, no? And if there is no one to transcribe, pwede na rin yung VI ang magbabasa ng kanyang sagot. So in that way, you're able to assist him, and he is able to use his tools in performing the given task. In this technology-driven society of ours today, our students who are blind and visually impaired are also very keen on the use of technology, and particularly the assistive technology. And I think it is just appropriate for you to be familiar with all these technologies, both the low tech and the high tech technologies. Here are some of the low tech assistive devices or technologies that our blind and visually impaired students can use. We have the Taylor Slate, Cuberism, and the Cranmer Abacus. These are mainly useful in performing calculations, mainly in arithmetic, and sometimes we use it in algebra, in synthetic division, finding square roots, and even in matrix operations, so in quantitative analysis, and so on. But of course, the main use of these devices is really in arithmetic. Next, we have here a set of geometric tools or devices that our blind students can use. We have a braille ruler or braille measuring devices. We also have braille protractor, uh, some special right triangles, and so with the other, we have compass here and some drawing devices. No, we have a tracer or a tracing pen.
Okay.
Next, we have here a an adapted geo board, and this is very useful, no, in different math areas and in algebra, trigonometry, geometry. I am really a fan of this tool because I can make use of this in not just in math but also in other subjects. No? So with just the use of pins, rubber bands, and even yarns, and so with other strings, no, I can make use of I can make different figures, although it's just two-dimensional, but it's really helpful, no? And this is one of the favorite tools of my students. And you can also make an adapted one, just using cardboards, and so with other indigenous materials. uh, I even had or met a math instructor in college that made this one a project for his math majors. So making accessible instructional materials. Another low-tech material that is very useful also, especially for geometry and other dimensional mathematics, is the use of a tracer or a tracing wheel and a tracing paper. This is this tracing wheel is the one that is used by our sewers or yung ating mga mananahi, no? So this is basically used to make diagrams or make raised lines. Napakadali lang po siyang gamitin, no? Parang ipe-press, i-roll mo lang. Pwede ka nga rin gumamit nung tracing pens or tracing other tracing materials, no? Kasi yung tracing paper na to, you can just make different lines or different figures, two-dimensional, 2D figures using these materials.
Okay.
Now we're done with the low tech. Let's move on to the high tech assistive technologies. Firstly, we have these two, which are the most common assistive softwares. We have the screen readers. Basically, it converts the text on your screen into audio output, and that's what I am using, and I think Sir Ronald is also using. Um, but in relation to math learning materials, if uh, these materials are encoded or are produced, using math type earlier, using the Office equation editor, particularly for Microsoft Office 2019 up to 365. No? This would be very accessible now with our screen readers. The screen magnifier is basically for the low vision, to magnify the text on the screen, and with different backgrounds that the low vision can make use of, you would be able to access the text on the document with this software. In reference to accessible graphing calculators, we also have some assistive technologies that are useful in creating um, graphs, particularly graphs that are audible, graphs that can be accessed by our screen readers and screen magnifiers. So we have three, at least three assistive software. So we have the audio graphing calculator, and this is a paid application. The audio graphs, this one is free, and the Desmos graphing tool, which is a browser-based uh, graphing tool, no? But um, these assistive softwares, no, can really make a difference in our students with visual impairment if they need to draw graphs or need to illustrate some functions or equations, whether it's in the basic math or even in higher math, then they can make use of these technologies. So they can even export or print what they have drawn on these softwares, and they can submit it to you. So hindi na talaga ganun ka problematic ang graphing for our students.
Okay button.
With that, I'd like to end my presentation by sharing with you this verse from the book of Isaiah, chapter 42, verse 16. And I really believe that our students with visual impairment coming from the Philippine National School for the Blind would be very blessed to have you as their math instructors. And we really hope that you will be guiding them in not just in their math class, but throughout their higher education journey. Um, we also believe that you will be miracle workers to the lives of these students. So once again, thank you and God bless us.